But let's start again. So I hope that you are listening me again in this session. Are you listening me? Hello, my students. Are you listening me?
Yes, sir.
Yes, sir.
Okay. So let's start it again. I was at this position maybe. This is something. Yeah. So randomly chosen crossover point. This was the column on which I was discussing something. So these numbers are just mentioning that this member one is going to be a partner with member two, and this is mentioned here. I can use also this annotation if it is. hmm. So this is going to be a partner with two, and this two is going to be a partner with one. So one is going to be a partner with two, that is mentioned here. And uh, two is going to be a partner with one, that is mentioned here. So all this is something that I just explained in a little bit previous session. And then there is a crossover point which we have to select randomly. And suppose for this member, with this first member of the population, we have selected this crossover point randomly at after the fourth bit. So 1, 2, 3, 4, this is 4. After fourth bit, we have selected this crossover point. And we know that this first member is going to be a partner with the second member. So then the crossover point for both the members should be same. So that's why this is again fourth after the fourth member. And that's why it is mentioned here 4 and 4. So this is something same. So now the crossover point for the third member is after the second bit. Uh, and this is the point mentioned here, and it is mentioned also here, second. So we know that third member is going to be a partner with this fourth one. So then the crossover point for both the members should be same, which is mentioned here. So now this column is again clear. So after applying the crossover point, we know that we have to replace the tails of these two members with each other. So the tail of second member, which is, I can change the color so that you can. So the tail of this one is 0. We have to change this tail, or we have to shift this tail of second member in the first one, and then we will get 0, 1, 1, 0 and 0, which you are getting here. And then similarly 1, 1, 0, 0, and then you have to shift this one. You have to shift this one in the string of the second member, and then you will get this string 1, 1, 0, 0, 1. So this is what. So this is the crossover operation that you are performing here. And after crossover operation, we are getting these strings in the new population. Similarly, you have to do the same operation with the third and fourth member, but here the crossover our point is after bit 2, and then I will get 1, 0, and all three zeros here after shifting it here, and then 0, 1 and 0, 1, 1 here at the above portion. So this column I am getting here after applying the crossover operation according to the point selected randomly. So now the decimal value of these strings will be changed, and now the value of the variable x is, this is becoming 12, this is becoming 25, and 11 and 16 respectively, according to these strings. And then you have to calculate the um, f of x. You have to calculate the square, and then you have to divide this value 144 with the average, and then you will get the fractional value according to previous step. And then you have to round these values again, as you have done in this uh, previous. For example, on this slide, if you remember, on this very first slide of this example, we performed these operations. We calculated fitness function and we have rounded these values up. So you have to perform those operations again, and all those operations are mentioned in just in this one column. So 12 multiplied by 12, I have 114. So I have to sum up these values, and I am getting 1146, and dividing it with 4, I am getting average 287, and the maximum value is maybe 625 here. And then 144 divided by this f average, according to this formula, I am getting 0.32, and similarly other values. And then I have to round these values up. So for example, after rounding it up, I will get 0, 1, and then 0, and this is 1 after rounding it up. So now I am not getting 31 here in this new population. What would be the numbers are the bit string for 31? Maybe 1, 2, 3, 4, and 5. So 1, 2, 4, 8, and 16. 16 and 8, 24 might be, and then 20, 16 and 24, and then you have to add 4 again. You will get 28, and then the last 3 bits. It means that for 31, all bits would be 1 for 31, if I want
Yes,
to
sir.
get 31 here in new population. So I am not getting 31 here in this new population. So now what I have to do, I have to repeat, or I have to iterate this process or operation again. So, but before that, we will understand this concept. But here, these are the next processes, and here we are getting this 31. So, but before that, we are going to understand these some other concept in which the mutation is involved. So this is the slide for that purpose. So in genetic algorithm, in this source code, we have mentioned here the mutate, child, mutate. We are mutating some child and getting this child. If small random probability, this is a condition mentioned here in this algorithm. And I told you at that time when we were discussing this algorithm, that this statement will not execute at each time, because it is depending on some kind of probability, and when that probability condition will be fulfilled, then we can mute any child that we are getting after this recombination or reproduction process here. So now we are going to understand this uh, probability concept, which is involved uh, for the mutation operation, or for, you can apply the same concept only for the inversion operation also. So we are assuming that uh, uh, the probability value is 0.001. So just assume it. We are assuming What this value means, it value means 1 over 1000.
1000.
So which means that if we apply this concept here on this our example, which is about the bit string and string, so we can say that in 1000 bits I can mutate only one bit. Okay, this is the meaning of this 0.001 or 1 over 1000.
Okay,
So
sir.
if I am assuming that I have 0.00001 value, then it means 1 over 1000. Then in other words, it means that among 1000 bits of the strings that these are the bits that you are getting in each population and in the members of the population. So in 1000 bits, I am allowed to change one bit. This is the meaning of this 0.001. So in our example, we have four subjects. In our example, we have four subjects, and each subject is taking 5 bits. We have 1, 2, 3, 4 subjects, okay? Or you can say 1, 2, 3, 4 subjects. And each subject, our member is taking 5 bits. So 4 multiplied by 5, and then you have to multiply this assumed value with this value, and we are getting then 0.02, which means 2 divided by 100. So this is your final answer, that you can change 2 bits in 100 bits at any time. So you can fix this in your source code, that if you have not processed 100 bits, or you can fix this in your source code that up to 100 bits you can mutate 2 bits anytime, and then you can apply this thing as randomly. For example, randomly you are selecting some bit at any time during the process of the genetic algo, then you can do this operation only 2 times, and then you have to check in parallel that either you have processed the 100 bits or not. If you have processed the 100 bits and you have applied the mutations 2 times, then you are not allowed further in this 100 category of bits, in these 100 bits. So this is the meaning, and now you can apply this concept in your genetic algorithm at any position. And now we are going back. So any question uh, at this slide? No, no, any question? Am I
No,
explaining?
sir. No, sir.
Am I explaining in a very well way that you don't have any question or something other?
सर अभी तक कोई क्वेश्चन नहीं सर राइज हुआ सर.
Achha, that means that I am explaining all the things, huh?
Yes, sir.
Okay, let's move on. So now this is something that we have understood now about the mutation and the probability value. So now we can continue with our process of genetic algo with the bit string that we are taking already. So these are the bit string 0, 1, 0, 0, 0, 1, 0, 0. So 0, 1, 0, 0. So so this is the population that we have up to that point. And then we are again selecting the partners. So one is going to be a partner with the third one. So, and then third is going to be a partner with the first one. It's clear. And second is
Yes,
going to be a partner with the fourth one. And fourth is going to be a partner with the second one then. So it's clear from these numbers. And then the crossover point, again, randomly that you have to do is for the first one, the crossover point is after 3 bits. So after 3 bits here, maybe I can use annotation here again for just, so after 3 bits here. So, and this one is the partner of the third one. So the third one is again after 3 bits.
3 bits.
So now change it 0, 1, 1 and then 1, 1. So I am getting this string. And then 1, 1, 0 and these both 2 zeros here. So I am getting this one. So this one and this one. And then you have to change it. These are the decimal value for these strings. And now you can count. In your algorithm, you can count how many bits you have processed up to this point. We know that we have not processed 100 bits up to, these are only 20. 4 subjects and containing 5 bits each
Okay.
in each member. So this is something 20. 4 multiplied by 5, 20.
Yes, sir.
So this is 20 and the previous generation is 20, 20 plus 20, 40 something. So we have processed, just to clear this annotation and then. So in these previous, so this was the first 20 bits. Then I
Yes, sir.
got these 20 bits again, so 40. And now
Yes.
I am getting these 20 bits again, so 60 bits total. So according to previous slide, if I want to apply the mutation operation, then I have the chance here because I have processed 60 bits and I didn't apply the mutation operation yet. And here in this situation, uh, I can calculate the difference of this member with the final member 31, for which I have all the bits 1. I can calculate the difference in my source code. And then the difference, if the difference is only 1 bit, like this one, then I can apply the mutation operation also without any probability. Or you can apply the concept of probability also. It is up to you. It is the design of the algorithm. You can apply the concept of the probability according to the previous slide. This is one approach. Or you can apply the concept of this mutation here, because there is a difference of only 1 bit between this member and the final 31. So it is always good if I apply mutation here now without any probability. Okay, the difference is only 1, then I can also calculate the from my probability that how many bits I have processed. So I have processed up to this population, I have processed 60 bits, and I am allowed to mutate 2 bits among 100 bits.
100.
So here, this is the position according to my conditions. I can apply this mutation operation here, and then I can end up my algorithm, because then I will get this 31 here, which is something I needed. So one thing, we can apply the mutation here, and then we will get the member 31 here in our population, and then
Yeah.
we can end up our algorithm here at this point. If, for example, we are not happy with this option, then we can move on to the next step or next iteration. And then this is the population. Then it means that one is going to be a member with second, be a partner with second, and here it is mentioned second. And then second is going to be a partner with the first one. And similarly, third is going to be a partner with the fourth one, and
Fourth
fourth
one.
is going to be a partner with the third one. It is,
Third one.
and these are the crossover points, 1 1. So after first bit, so just to after first bit. So this is, I am closing my algorithm forcefully, because I know that only 1 bit is needed. So and it is randomly, so I just mentioned 1 1 here, just so that the genetic algorithm will be over. Otherwise, it is up to the machine actually what random number it will generate and where we will go. Anyhow, so this is the difference between the machine and the human being. So, so after selecting this crossover point 1111, now this is something we can understand after applying the crossover operation. This is one and this is one. One is this first member is going to be a partner with second. So and the crossover point is after,
Zero.
yeah, after this first bit. These two members. So just replace this tail here and this tail here down. So then the second member will become uh,
31.
31, which we needed, and the first one will become all zeros. So this 31 I needed, and then we can end up with our algorithm. Uh, Anyhow, so this is the simple example of genetic algorithm, and we have seen uh, the all the four processes are the steps involved in genetic algorithm. This same idea you can apply here on this eight queens problem. And in this eight queen, we know that we have to place queens in all the squares. And the condition would be that no any queen can attack another queen in this scenario. And on this slide, you are seeing different solutions for that eight queen problem that you have studied in your previous chapters, maybe. But this is only idea. So this, and then you can get or you can get the detail from the internet anywhere. So what you have to do, for example, this is the solution, and this solution we can represent it with a simple string. So for what is the this is square one, this is square two, three, four, five, six, seven, and eight. So this queen is at position one, starting from zero. If starting from zero, then it would be seven maximum. So starting from zero, then the position of this queen is one, and the position of this queen is 6, which is mentioned here. Position of this queen is 2, and in this way you can
2.
write this string. It's clear. I think it's easy. And similarly for this thing, you have to
Yes.
write all the positions of these queens here, and then you are getting a string for that solution. So now you can understand. So these are the, if we can apply the genetic algorithm in the same way, and then we have to find this solution in the population. Okay. So now maybe you are understanding or getting that idea. Anyhow, we will see some other detail about this eight queen issue. So all these are different solutions of eight queen, and you can just represent the solution state with these strings that we have. Now, what you have to do, we have to simply, for example, if we have these two members, this is something, a string. Now you can understand what this string is meaning to you. And this is another member, and you have a string for this state also. What you have to do here, we are understanding the concept of crossover for this for these eight queens, and then where we are getting a new state accordingly. So this member, just the crossover point is this one after the third column. And this, if this is the crossover point, and if this is the crossover point, this is the same for the second member also. And what you have to do, you have to replace this tail here and this tail maybe here, but here only we are showing only one member. But if according to genetic algorithm you are getting two members, then there is another member that you have to show somewhere here on the slide. But on this slide we are only getting one child. So replacing the tail of second member in place of first member, and then you are getting this new state. It is also highlighted with this yellow color to understand the things easily. So this is from the first member. This is the position from the first member of queens, and this is the
Yes.
position from the position of the
Second.
queen from the second member. And we are joining, we are crossing over, and we are getting a new string according to these positions. So nothing else. So now we will try to move on to the next slide. So this is basically the complete illustration, but this is just only an idea. You can find the details of this topic by yourself. So here, these are those strings that we have on the previous, these strings. So we have these strings, or we have some kind of strings here, and this is something, the fitness value of those strings. Then we are calculating the chance of selection according to these fitness values. You can sum up these values, and then you can take 24 divided by 24 multiplied by 100 divided by the total sum, and then you will get this value. So anyhow, this is an incomplete example. So we are only getting the idea, but you can understand this example in detail from different sources that are available on the internet. So anyhow, so this is the percentage of the selection. First, we are, for example, making pairs. So this is 2, 4, 7, 4, 8. So you are writing this member. Simply, you are mentioning this member here at this position, and you are writing this member here at this position. And then you are selecting a crossover point. This is the crossover point, and then you have to swap this tail here and this tail here at the second member. And this is what you are getting here: 3 to 7, and then this one 4 8 5 5 2, and then 2 4 7, and then 5 2 4 1 1. And same is you have to do with these members. Okay, so this one 3 2 7 4 8, something like that, and this one bit which is highlighted in some way, this is the operation for this mutation.
Station.
So you can apply mutation at any point, and if it is mutation, then you can change one number in from 0 to 7. You can change any number in this string. You can select that and you can replace it with any number from 0 to 7. So this is the mutation. So all are the same operations you can apply, which are the operations of genetic algorithm. You can apply here with this example, and then your algorithm will find these solution by itself. You can understand. Initially, these are the solution strings. So when you will find any solution string in your genetic algorithm, then you can make your algorithm to be ended. So additional reading from TV textbook chapter 4. So this is textbook, not the reference book. So you have to go into your textbook, and in your chapter 4, you have to read this contingency and online search by yourself. And this is the project 4 that you have to do. implement a basic binary genetic algorithm for given problem, you have to visit this link, and you will see the source code there, and you have to understand the source code there first, and then you have to download, then you have to configure it, then you have to run it on your machines. And if you have the understanding of the source code, then you have to write the report finally for this lab project. And the format of the report I already explained with you all guys. So the first thing, that this is the end, and now I am going to end up this video. Do you have any questions? I am just going to end this video, and then afterward we can talk normally without this video. So I am going to just